So we're actually going to go on now to 7.3. So we did 7.1, and we're going to do 7.3 today, not 7.2. 7.2 is its own little section. We'll do that tomorrow when we get back. 7.3 is going to answer the question, well, what if these things don't simplify in a nice way? Okay, like what if we have the square root of 50, right? We can't do that with what we know so far. And 50 doesn't have a perfect square root, right? Now, there's two main ways to do this. And both ways really kind of work because of the product rule for radicals, which I don't even want to deal with. We're just going to talk about how to simplify this. There's the factor tree way, and then there's a perfect square way. I use the factor tree, and it's what we talked about already in 7.1. But I'm going to simplify these with a factor tree to keep it consistent. Now, if you know how to simplify these already without the factor tree, you're more than welcome to do that. It does not hurt my feelings at all, okay? So do it the way you want to do it. But if you have no idea on how to simplify this, the factor tree way is probably the way you were first taught how to do it. So it might seem a little familiar. So here's how you would do this. So the factor tree way to simplify a radical is you take the radicand. If it's a number, if it's an exponent or a variable, we'll get to that in a minute. But if it's a number, you're going to take the radicand and you're going to break it down. I know that's 25 times 2. That's prime. We've got 5 times 5. Those two are prime, right? Okay. And now I have to know what root I have. I've got a square root here, right? So I'm looking for pairs. Underneath this radicand. Really, I'm looking for pairs of factors because it's a square root. And notice 50 is 5 times 5 times 2. Hey, there's a pair of 5s here. Okay? There's a pair of 5s there. So what that means is those 5s can leave the radical. Think of it like going on a date night. Okay? This is my goofy story I tell every time when I give this lecture. Think of it like a date night, and the 5s can leave, but when they leave the radical, they're going to leave as 1, because really what you're doing is taking the square root of 25, okay? But this 2 here, it does not have a date, okay? It does not have another 2. It's got to stay home. It's got to watch. It's going to watch The Notebook, and it's going to eat Ben and Jerry's and enjoy itself, okay? But it can't go out on the date. It's got to stay home under the radical. The Notebook, Juno, that's another sad one. Miley and Me, what was it? Not Miley. Marley and Me. That was legit sad. But something like that. So anyway, that guy, if it doesn't pair up, now if it's cube root, we're going to find 3 of a kind, right? But if it doesn't pair up, it's got to stay underneath, okay? It's got to stay underneath. So I'm going to do a few of these just so it becomes more familiar to you. So let's say we had... let's say we had the square root of 24. Again, square root of 24. 24 does not have a square root, right? So automatically, I'm going to start breaking it down the 24. Now, I know it's what, 12 times 2. That's 6 times 2. And that's 3 times 2, right? So the prime factors of 24 are 3 times 2 times 2 times 2. Now look, I'm still looking for pairs, not for 3 of a kind. I see that I have 3 2s here. I'm not worried about that. All I need to know is I've got a pair of 2s there. So that 2 can come out. Okay? The 2 doesn't pair up here, right? There's not another 2, so it's going to stay underneath. The same thing with the 3. There's not another 3, so it stays underneath. Okay? So you wind up with 2 square root of 6. Okay? 2 square root of 6. I know it's cool. You have to. So this is simplifying. Actually, if you wanted to look this up, on YouTube to watch somebody else do it. It's called simplifying radicals using the factor tree. Okay, simplifying radicals using the factor tree. So let's say we had another one. Let's say we had hold on, let me think. Ooh, let's say we had the square root. I'll seek the square roots for now. The square root of 72. I want you to try this one. You try it. It's a little different. It's not like the first two. So try the square root of 72. It's okay if you get it wrong. Okay. So I'm going to break down 72. Let's see. Oh, man. It's like what? 8 times 9? Then 9 is that right? I feel like it's right. That's 72, not 79. Then 9 is 3 times 3. And I know 8 is 2 times 2 times 2. So you guys should have all gotten to this spot where in the end, it doesn't matter the order because it's all multiplication. But it winds up being 2. I'm going to write down here. 2 times 2 times 2 times 3 times 3, right? Those are the really 5 prime factors of 72. But now I'm going for square root here. So I'm going to circle the pairs. I got a pair of 3s and I got a pair of 2s, right? One of my 2s is going to have to stay put under the radical. So if I was going to simplify it, or if I am simplifying it, I'm going to take a 2 out because we had a pair of 2s. Take a 3 out. Now look, this is all multiplication here, okay? And then the square root, the 2 is going to be left over. So you wind up with 6 square root of 2. Excuse me. Okay. Now I'm going to use that same radicand, but I'm going to do a different root here just to show you how it looks different. So let's say we had the cube root of 72. Okay. The cube root of 72. Now look, it breaks down into the same 6 numbers or 5 numbers, right? We know that 72, when you break it down to its prime numbers, are right here. 2 times 2 times 2 times 3 times 3. Okay. But the difference is we're not looking for 2 of a kind now. We're looking for 3 of a kind. And for 3 of a kind, we do have 3 of a kind here, right? We got 3 of a kind 2s. That's a group of 3, right? So that means for the cube root of 72, I can take a 2 out. Now look, these don't pair up in a third. This is a little different kind of date here, but these don't have 3 of a kind, the 3s. So they have to stay under the radical, 3 times 3. So you wind up with 2 cube root of 9. So 2 cube root of 9 if you simplify the cube root of 72 compared to the square root of 72. Okay? Okay. So let's look. Now I'm going to kind of start where the book starts because then we'll get to this stuff as we go. But the book kind of starts with 2 rules we're going to use. One of them, I think both of them I've really kind of used in the lecture already. But the one is the multiplicative rule of radicals. And it says, look, if you have the nth root of A times the nth root of B, you can multiply radicals together. Now they have to have the same root, and you can combine them as the nth root of a times b, okay? And vice versa, which is nice. So like I'm going to steal kind of an easy one in the book just to kind of get you comfortable. Like number 2 says if we've got the square root of 11 times the square root of 10, this would just be the square root of 110, okay? Just the square root of 110. Not a big deal. This is let's give it the actual name that the book gives it. Product rule for radicals. Okay, product rule for radicals. Now, the quotient rule is what we actually kind of did earlier. I kind of brought it up beforehand, but the quotient rule says if we've got the nth root of a over b, and just like the exponent stuff, we can take the nth root of a over the nth root of b. Okay, that's just the quotient rule. So let's see. Let me look at an example they're going to give you. Now they kind of do this. Oh no, they don't do it backwards. They do it that way. So this is like number 14 in your book. Number 14 says, what's the square root of 10 over 81? Well, I know with the quotient rule, it means I can take the square root of 10 over the square root of 81. Now look, I don't think 10 simplifies. If we try to do the factor tree on 10, it's just 5 times 2, right? It doesn't pair up with anything. It's not 2 5s or 2 2s. So that means the square root of 10 is simplified. You just have to leave it as the square root of 10. But 81 we know has a square root, right? The square root of 81 is just 9, okay? It's just 9. So this would be the answer for the square root of 10 over 81. When you use the product or quotient rule, do the top and bottom. Square root of 10 doesn't change. Square root of 81 is just 9. Okay? So let me kind of do a few more of these from the beginning that are a little more complex, or maybe you have to like kind of solve them or simplify them kind of at the end. Let's say we had, this is number 4. We've got the 4th root of 27 times the 4th root of 3. The 4th root of 27 times the 4th root of 3. Now, I'm going to have to bust the calculator out and look up 27 times 3. I should be able to do it in my head. Oh, it's 81. Oh, we know what this is going to be. The 4th root of 81. Now, remember, 81, if you want to go back, turns out to be 3 times 3 times 3 times 3, right? And we are doing a 4th root. Notice there are 4 3s. And look, there's no leftover numbers, right? So that means the radical goes away. It's not like the ones we did a minute ago. Hold on. Let's look at this real fast. I'm going to bring this down. It's not like the example like the square root of 72, how we had like leftover 2, so it had to stay under the radical. This one, everything is included in my group of 4. So therefore, there's not going to be a radical left over at all. This is just going to be 3. Okay, just going to be 3. Okay. Yeah, I'll let you try it. Okay, so let's get some other ones going on. Let's say we had, I want you to try to simplify these. These are really what we did at the beginning of this, the 7.3 section. Let's do 34. We've got the cube root of 108. Try that one. And then jumps into numbers, which is fine, or variables, but let's do the 4th root. I'm making this one up. So the fourth root of 162. So try those two, the cube root of 108 and the fourth root of 162. Okay, keep working if you're working. I'm going to start simplifying these, and sometimes they just take a little while. So 108 breaks down into what? 54 times 2? And then 54 is what, 27 times 2? 27 is going to be a bunch of threes, right? 9 times 3, and then 3 times 3. That's what I got. 3 times 3 times 3 times 2 times 2. And then, no, 27 times 4. Yeah, that's right. So now we're doing cube root, so I can take out the 3. But these two don't pair up. We need another 2 to pair up because it's a cube root. So it leaves me with 2 times 2. So I wind up with 3 cube root of 4. Okay. So 162, man, we're looking for 4 of a kind here. Holy cow. So 162, oh, that's our 81 again. It's 81 times 2, right? And then there's going to be a bunch of 3s, 4 of them. In fact, now I'm going to be lazy just because I did it up here already. This is 3 times 3 times 3 times 3. And the 3 comes out, that 2 has to stay. So this becomes 3 fourth root of 2. Okay, 3 fourth root of 2. Okay, so now let's look at variables. Well, how do you simplify a variable with this example? So let's say I've got okay, well, first off, let's review. Remember, if it was like the square root of y to the 6th, it's how many times does 2 go into 6, right? It's just y cubed. So what if we looked at, like, let's say the square root of y to the 7th, right? It doesn't divide evenly. I'm going to go over kind of the hard way to do this, and then I'm going to show you the easy way, just like I did last time. Okay, so the premise of this comes from the fact that you can break apart this y to the 7th into a variable that does have a square root. Y to the 7th is just y to the 6th times y to the 1, right? And I chose y to the 6th because I know it has a square root. So this would be, well, the square root of y to the 6th is just y cubed, right? I can't put 2 into 1, right? 2 doesn't go into 1 because it's less than that. So therefore, it stays. Okay, it stays. So this would be the simplified version of this. And it's okay if you're like, oh my God, I don't see that. I'm going to show you kind of a quicker way here to do in a minute. But I feel like the math gods will kind of strike me down if I don't show you this. Okay. So if we had one like, let's say the 4th root of x to the, let's say x to the 15th. I'm going to kind of go by 15 and just think down, you know, like kind of count down from 15 until I get something divisible by 4. So 15, no. 14, no. 13, no. 12, yes. 12 is divisible by 4. So this is going to be x to the 12th times, now to get 15, remember, you're adding. So you're multiplying. So x to the 12th times x cubed. And then I'm gonna take the 4th root of both again. So the 4th root of x cubed is just, the 4th root of x to the 12th is just x cubed, right? And look, we can't take 4 into 3, so it has to stay. So that's just sitting put because I can't take 4 and divide it into 3. Let's do like one more, and I'll kind of show you off the 3 examples how to do this. Let's say we had the cube root, since we did square root and 4th root. Let's say cube root of y to the, let's say y to the 14th. Cube root of y to the 14th. Well, in this one, think about this. Now we're trying to find something divisible by 3, and I'm going to count down from 14. 14 is not divisible by 3, right? 13 isn't, but 12 is. So I'm going to think of this as y to the 12th times y squared, because 12 times y squared times y to the 12th times y squared would give me that y to the 14th. And then I'm going to take the cube root of both of these. So the cube root of y to the 12th is just y to the 4th, right? 3 goes into 12 4 times. I can't take 3 into 2, so it's going to stay under the radical. Okay, so here's the quick way to do this, so you don't have to go through all that. You're really dividing and you're getting remainders, okay? Like if we look at 2 divided by 7, let's go back old school on when you first learned how to divide, right? How many times does 2 go into 7? 3 times, right? 2 times 3 is 6. You subtract it, and this was called the remainder. That's the exponent left over, okay? That's the exponent left over. This is what you take out, y cubed. That's the remainder, y1. So like if we look at this, the 4th root of x to the 15th, how many times does 4 go into 15? Well, it goes in 3 times evenly, right? 4, so I mean, really, I'm doing this in my head. It's going in 3 times evenly. 12, you subtract it, you're left with a 3. So that's an x cubed left over. And say like y to the 4th, or 3 to 3, oh my gosh, the cube root of y to the 14th. Well, how many times does 3 go into 14? It goes in 4 times evenly. That's 12, but then you're going to have a 2 remainder, okay? You're going to have a 2 remainder. So that's the quick way to do it. The exponent underneath is just the remainder of the radical, the root and the exponent of the radicand. So I'll show you one that isn't one we've just already done here. Let's say I had, I'm going to steal one from you. Yeah, okay, let's say I had the cube root of y to the 10th power. So to do this one in one step, I'm going to think, well, how many times, now it only works with exponents, guys, only exponents. How many times does 3 go into 10? 3 times, right? But what would the remainder be? What would it be? 1, right? Yeah, it's going to be 1. Why the first power? So boom, that's it. Okay, 3 goes into 10 3 times, that's 9, right? And we'd have a remainder of 1. Okay, and now I'm going to do a few that kind of combine numbers, actually that do combine numbers and variables. So if we looked at, this is number 44, the 5th root of 32 z to the 12th power. And again, I'm now mentally, what I'm going to do is think of these as 2 separate radicals. Okay, I'm going to think of these as the cube root of, or the 5th root of 32 times the 5th root of, not y, but z to the 12th. Okay, and then I'm going to work them kind of separate. So the 32, it's a lot of 2's. 16 times 2, 8 times 2, 4 times 2, 2 times 2. Okay? And look, I've got, hopefully we have 5 of them. 1, 2, 3, 4, 5. Yeah, we got 5. So that turns out to be just 2. The 5th root of 32 is just 2. So we don't have to worry about a radical there because we took the entire 5th root of that number. There was no leftover factors. But now z to the 12th is going to be a little different because how many times does 5 go into 12? Well, 2 times, right? And then we've got a remainder of 2 as well. Okay. Steal another one. They had just more square root. Because I'll tell you, square root's what we're going to be dealing with the most. Let's look at 56. I want you to try this one. Now, it's got 3 parts, but think of simplifying each one of them. So we're going to do the square root of 12, r to the 9th power, and s. Now, I don't like s's in algebra aren't good because they kind of look like 5s, but that's why I make it look goofy. But s to the 12th. So try this one and really simplify each part, okay? Simplify each part. You keep working it, working. I'm gonna start breaking it down. 12 is what? 6 times 2, 3 times 2. Hey, I've got 2 2's here. Now this 3 doesn't pair up. So I'm gonna start by kind of writing the radical, and it's gonna be things under it and things out of it. Okay. This 2 I know is gonna be out of the radical. That 3's got to be in the radical. Okay. Now let's look at r to the 9th. Well, how many times does 2 go into 9? It goes in 4 times, right? But we have 1 left over because 2 times 8, that's 8 plus 1. Now, s to the 12th, though, 2 does go evenly into 12. That's going to be 6. And there's nothing left over. So there's not going to be an s under the radical. Now, I'm going to clean this up a little bit. So it's going to be 2r to the 4th, s to the 6th, square root of 3r. It honestly looks more unsimplified than when we started, but that would be considered the simplified version. Okay. And when we carry on to like 7.4, 5, and 6, you'll see it'll make more sense because we're going to simplify out of this. And to simplify, like say fractions or multiplication or anything like that, you've got to have things out of the radical to keep going. Okay, you've got to have things out of the radical to keep going. Questions, comments, concerns? Hold on. Give me just 1 minute. Oh yeah, we're like done, aren't we? Okay. So I'm gonna challenge you with this homework a little because I haven't done as much, but I'll kind of expect some questions when we get back tomorrow morning. So this is actually 7.3. So remember, I'll have to change the way the lecture is titled. It's 7.1 and 7.3. Starts on page 533. And the first part is just the multiplication and quotient rule. So I want you to do 1 through, oh yeah, we haven't done the bottom. That's fine. We'll do those tomorrow. If you don't get through this completely, that's fine. I know it's a lot to give you for 1 day's worth of homework. I get that completely. But what I want you to do is instead of, if you know you can't complete all of this, this is odd. If you know you can't complete all of this, start doing a few from 7.1. And once you get the hang of it, go on to 7.3. Okay.